And I must continue, and I must continue, and I'm sharing screen now. And we're opening up by looking at angles and measure. I don't need these earphones in. Anyway, right, find the measure of each angle. Okay, so it's going clockwise, and that's a 90 degrees there and 20 degrees there. So I would say that it's negative 110 degrees. It's going clockwise as well, and it's in degrees, so 360, 720, then 720 plus 90 is 810, plus another 90 is 900, plus what? Plus 40. So 940, but I put a minus sign in front. And I check. And that's good. Next up, radians, radian measure. So this is going counterclockwise or anti-clockwise, so it's all good. It'll be positive. So let's see, 2 pi radians, 2.5 pi radians, plus pi over 6, plus pi over 6. So I can do 2.5 plus 1/6. Now let's see, a half plus a sixth. That would be 4/6, which is 2/3. So it's 2 2/3, which is 8 over 3. So 8 over 3 pi. I should say all of that is multiplied by pi. Next, let's see. Okay, so 2 pi plus another 2 pi, so 4 pi now. And look here, instead of pi over 2, it's pi over 2 take pi over 4. And when we do that, we get, well, pi over 4. So it's 4.25 pi, which is 17 over 4 pi. That many radians. And we check, and that's good. Draw an angle with a given measure in standard position. So this is 5 pi over 4. So that's like 1.25 pi. And a quarter pi is 45 degrees to translate that. So there. And you need to indicate that. Like so. And let's see here. That'll do. Now notice they have the arrowhead there on the spiral. So imitate, and there you go. Negative 47 pi over 18. Double 18, you get 36. And what's the remainder? It would be 11 pi. So it's the negative of 2 pi plus 11 over 18 pi. The negative alerts me to the fact that it's going clockwise. So it makes one full turn. Now 11 over 18 pi. Well, if it were 9 over 18, that would be half of pi, which is a 90-degree turn. But it's a little bit more than that. It's 2/18 pi more than that. So I can signal it like this. Like that. And I can do this. I continue and do this. And so that would be 2 over 18 pi. And we check. And that's good. 170 degrees. It's up to you how you wish to signal that. I would put 80 degrees in there personally, because that's more visible. And they have it as a ray emanating from the origin, like that. Now, 510 degrees. Well, that's 150 degrees more than 360 degrees, which means that I must do this. 360, 450, and then 60 degrees onwards from that. So about there-ish. And that sort of completes it, and that's good. Find the reference angle. Reference angle. So I kind of think of it as the smallest angle to the horizontal. So anyway, we must try. Okay, well, that's nearly 4 times as much. So let's see. 1. Nearly 2, but it's just a slither away from there. In fact, it's 1/12 pi, isn't it? But I may need a reminder about that. Okay, and this says negative pi over 4, so I believe that it's pi over 4. Yeah, I really need to check this. No, these are valid. Nonetheless, I'm going to reference angle is the smallest positive acute angle formed between the terminal side of an angle and the x-axis. So essentially what I was saying earlier was more or less correct. Okay. Right, so that's 2 pi revolutions. There's a full 2 pi revolutions. And then it's just a 1/4 pi more. So the smallest positive acute angle made between the terminal side of an angle and the horizontal x-axis. I mean, it's pi over 4, but I'm just sort of reciting the definition. 530 degrees, so that will go clockwise. There's 360, 450, and 540 is nearly back to the horizontal, but it's just 10 degrees away. So there. 290, so we do the horizontal ray. And we turn now, so it's more than that, so there, like that. That's a good depiction. And how much is missing? 70 degrees. Negative 140. So it needs to go on by 40 degrees, so there. And I check that it's all correct, and that's good. Convert each degree measure into radians. Recall, 2 pi radians is 360 degrees. Pi radians is 180 degrees. Pi over 2 radians is 90 degrees. Pi over 4 radians is 45 degrees. Pi over 3 radians will be 60 degrees. And, now do it. Okay, so 60 degrees more. So that's going to be pi plus pi over 3, which is 4 pi over 3. 315 degrees, well, that's 270 plus 45. So that will be 3 over 2 pi plus, well, actually, it will be 2 pi take pi over 4. So 7 over. Is that right? No, that's not right. One and 3/4. That's 7 over 4, actually. 7 over 4 pi. 125 degrees. So just do this and simplify. So 25 over 72. And you can't really go further than that. So now do this and times it by this. You get the 2 on the top and the bottom, and so it cancels out, and so you get this. Then negative 340 degrees. Similar pattern. Cancel, cancel. Then times that by 2 pi. And we get negative 17 over 9 pi. And we check. And that's correct. Convert each radian measure into degrees. All right, so that would be 4 and 3/4 of pi. Now 2 pi equals 360 degrees. Therefore, this is 720 degrees plus 3/4 of pi. 3/4 of pi will be 3/4 of 180, which is 135. So 720 plus 135 is 855 degrees. pi over 4 should be known by now. That's 45 degrees. It's just hard to stick in memory. 18 doubled is 36. The gap then is 7/18, so it's negative 360 degrees plus take 7/18 of pi, and how to convert this? We'll recognize that 1 pi is 180 degrees, and we're dividing it by 18, so it would be correspond to 10 degrees, so that would be 70 degrees, I believe. So negative 430 degrees. Next, this is 18, and then we have to go on by 13, so negative 360 degrees. Take away 13 pi over 18, which would be negative 490 degrees. Check. No, not right. So fix it. Okay, I recognize the error. So that would be negative 310. Okay, and that's all good. Find 5 angles that have a reference angle of pi over 6. 5 angles with such a reference angle. Okay, well, first of all, pi over 6. How about that? And then you can continue to add 2 pi. So that would be, beg your pardon, that would be 12 on the top. Like that. Like that. Like that. Like that. There you go. How many solutions are there to the equation x degrees equals x radians? What an interesting conundrum or problem. One. One canonical solution. No, that's literally it. Just one. Just one. Okay. All right. So they didn't choose to do my sort of approach here. They chose a more efficient approach, I guess, but it's still valid, and so it's all fine. Next up, some right triangle trigonometry. So I must get my calculator ready. Get my calculator ready for such a task. And because we have the cosecant function and the tangent function. Okay, we need to find the value of each and round our answers to the nearest 10,000th. So the cosecant function is 1 divided by the sine function. So this is 1 over sine of 23 degrees. And just type that in now. And you get to the nearest 10,000th. So what I'm going to do is just say off a bunch more excessive digits, more digits than what I need. Dot, dot, dot. And then think. To the nearest 10th would be there, 100th there, 1,000th there, and 10,000th there. So basically, they're asking for 4 decimal places. That right there is called my decider digit. It will decide what the value of that will be right there. And in this case, it will stay as 3 because that happens to be a 0. So 2.5593. Tan of 5 pi over 36. So you've got to make sure that your calculator is in radians for this, but it's a good exercise to turn this into degrees if you can. So pi radians is 180 degrees, and therefore pi radians divided by 36, well, that would be 5 degrees, and therefore this is tan of 5 degrees, a tan of 25 degrees. So I just type that in, and to 4 decimal places, that would be 0.4663, and check. Make sure it's correct. Yes, it's all correct. Find the value of the trig function indicated. So find the cosecant of theta in the case of this triangle. Well, the cosecant is 1 over sine, as stated. 1 over sine of theta. And sine of theta is, from right triangle trigonometry, is opposite divided by hypotenuse. So, I guess I didn't really just give everything away. Anyway, we've got to find the opposite here. So we'll just use Pythagoras' theorem. So 3 root 5, when you square it, you get 45. You get 45. And so 81 take away 45 gives you 36. And when you square root that, you get 6. So the cosecant of theta being the sine but flipped will be hypotenuse over opposite. So it'll be 9 over 6, which is 3 over 2. Tan of theta is the opposite side divided by the adjacent side. So in this case, would have to use Pythagoras' theorem, the Pythagorean theorem, to find out this adjacent side. So 484 take away 196, which is 188. And then, no, sorry, beg your pardon, it's 288. And root 288 is 12 root 2. So it would be 14 over 12 root 2. which is 7 over 6 root 2, but you must simplify. Multiply the top and the bottom by root 2, and so we get 7 root 2 over 12. And check. And that's good. That's good. Okay, tan of theta, by definition, by the ratio definition at least, is the opposite divided by the adjacent. And in this case, we're simply told what the opposite and adjacent are. It's 12 and 9. So I put 12 in that spot, 9 in that spot, and then I simplify, and I get 4/3. Secant of theta is 1 over cosine of theta. And because cosine of theta is defined as adjacent over hypotenuse, the secant of theta will be the hypotenuse over the adjacent. So in this case, that would be 15 over 10 root 2. Cancel out the common factor of 5 on the top and bottom. And then simplify the radical expression there, or the surd, if you like, times the top and bottom by root 2. And so we get 3 root 2 over 4. And check. And that's correct. And next one. Find the cotangent of theta if the cosecant of theta is 3 over 13. How to solve this? So let me just make that finer. So that's the adjacent over the hypotenuse. That's the ratio of the adjacent to the hypotenuse, 3 over 13 by definition. Cotangent of theta, by definition, is the adjacent over the opposite. So we don't have the opposite, right? Well, we kind of do. We can actually get it from the Pythagorean theorem. So do 13 squared, 169, and then take away 3 squared. So take away 9 from that, so 160, and then square root it, which is 4 root 10. 4 root 10. So put 3 on the top, and put 4 root 10 on the bottom, and then simplify, times the top and bottom by root 10. So 3 root 10 over 40, I believe. Now find cosine of theta if sine of theta is this. Well, sine of theta is the opposite divided by the hypotenuse, and cosine of theta by definition is the adjacent divided by the hypotenuse. So we know the hypotenuse in both cases is 17, but we don't have the adjacent, so we just do the Pythagorean theorem again. So 17 squared, that's 289. 4 root 13 all squared, that would be 16 times 13, which is 208. So take away 208, and we obtain 81, and square root that, which is 9, and that is the adjacent side. So put everything in its position now. So 9 over 17. Now check, and it's all correct, and that's good. Okay, find secant of theta if cosine of theta is root 2 over 10. Okay, by definition, cosine of theta is adjacent over hypotenuse. So write adjacent over hypotenuse. Secant of theta, by definition, is 1 over cosine of theta. So in this case, it's actually kind of easy. It's just 10 over root 2. But wait a minute. You have to simplify. So that would be 10 root 2 over 2, which is 5 root 2. Find the sine of theta if secant of theta is 5 over 3. Secant of theta is 1 over cosine of theta. Cosine of theta is adjacent over hypotenuse. So by definition then, this is hypotenuse over adjacent. Sine of theta is, on the other hand, opposite over hypotenuse. So we have the hypotenuse, it's going to be 5, but we don't have the opposite. So we just use the Pythagorean theorem, and this is obviously the 3-4-5 triangle, the 3-4-5 triangle. So it will just be 4 over 5. And we check, and that's correct. Okay, tangent of theta if cosecant of theta is just plain old root 10. Cosecant of theta is 1 over sine of theta. Sine of theta is opposite over hypotenuse. So cosecant of theta is hypotenuse over opposites. The hypotenuse over the opposite. So what am I supposed to do in this case? Put 1 on the bottom. Just there like that. Tan of theta, well, that's opposite over adjacent by definition. So let's see. So we have the opposite, it's 1. But we don't have the adjacent. So just do the Pythagorean theorem. Square root 10 to get 10. Square 1 to get 1. 10 take 1 is 9, and square root that to get 3. So it will be 1 on the top and 3 on the bottom. Tangent of theta is 1/3. Find cosine of theta if secant of theta is 5 over 4. Secant of theta, by definition, is 1 over cosine of theta. Cosine of theta is adjacent over hypotenuse, and therefore secant of theta is hypotenuse over adjacent. We can see that this is the 3-4-5 right triangle, the 3-4-5 right triangle. So cosine of theta being adjacent over hypotenuse, it'll just be 4 over 5. But also we could just see that these are reciprocal functions of each other. Okay, and that's all correct. Find the measure of each angle indicated and round to the nearest tenth. Round to the nearest tenth. So in this case, we know the opposite. We know the adjacent. So adjacent and opposite, oh, that would be tan, the tan function, tangent of theta. So we say tan of theta equals 10 over 13, opposite over adjacent. But now how to find theta, just use arctan, which reverses or undoes the tan function. So on your calculator, press Shift tan and then just type in 10 divided by 13 and close brackets, and we get 37.5685 blah blah blah, but we need it to the nearest tenth. So that's 37.6 degrees. Okay, here we have the opposite side to the angle. We have the adjacent side to the angle. So it will be the tan of theta again. In this case, it will be 3/2. So just do the arctan. Theta is arctan of 3/2, which is about 56.3 degrees. And we check, and that's all correct, and that's good. Next up, this pair here. So we have the opposite side, we have the hypotenuse. So who's that? That's sine of theta. Sine of theta is the opposite side, the length of the opposite side divided by the length of the hypotenuse. So sine of theta is 6/12. So just do arc sine. 6/12 is a half. Now I just know that that's 30 degrees. But always check with these things. And it is. It's 30 degrees exactly. That's one of the exact trig values that you're expected to know. In this case, what's the adjacent side? Well, it's this one here. 4.7 is right next to the angle. What's the opposite side? This one. So it's opposite and adjacent, so use tan of theta. So tan of theta is opposite over adjacent, so it's 16/4.7. So arctan of 16/4.7. And we get 73.6 degrees. And we check, and it's correct, and that's good. Now we have to find the measure of each side indicated, rounding the answer to the nearest tenth. So how to do that? Well, who's involved? Who's involved in this triangle? The hypotenuse is involved, the adjacent side is involved, and the angle theta is involved. So who mentions adjacent, hypotenuse, and theta? That would be cosine. That cosine relationship, right? Cosine of theta is adjacent divided by hypotenuse. So put everything in the best position that you can. Where theta is, put 52 degrees. Where the adjacent is, put 13. And where the hypotenuse is, put x. And now you have to find x. So you can, if you get stuck when you look at this and you're like, oh no, well, how do I do it? Just remember the 3, 6, and 2 rule. 3 there, 6 there, 2 there, right? It's playing the exact same role as these pieces. 3 is 6 divided by 2. Okay, I want 2. How do I make 2 from 3 and 6? Oh, I have to do 6 divided by 3. Oh, okay, so I have to do 13 divided by that. So x is 13 divided by cosine of 52 degrees. And then just put it in. And we get 21.1 Degrees? No, it's a length. So just 21.1. Okay, same story here. Who's involved? X, which must be adjacent, because it's adjacent to that 51 degrees. What about the 8 over here? Well, he's opposite. He's not the longest side, so he's not the hypotenuse. Instead, he is opposite. Opposite and adjacent. Oh, that would be tan. That would be tan of theta. Tan of theta equals opposite divided by adjacent. So put everything in its position. Where theta is, put 51 degrees. Where the opposite is, put 8. And where the adjacent is, put x. And now it's just like that situation over there. So x is 8 over the tan of 51 degrees. And we check and see. And we get 6.5. And we check these answers. And they're correct. And that's good. Who's involved? The opposite side, the hypotenuse. Opposite and hypotenuse, that would be sine of theta. Sine of theta is defined to be the length of the opposite side divided by the length of the hypotenuse side. Put everything in, so sine of 75 equals 6 over x. And now get x by just doing 6 over sine 75. And you get a third. So press the decimal button on your calculator to turn it into a decimal. So you get 6.2. Who's involved? Opposite hypotenuse. Who's that? Sine again. Sine of theta is opposite over hypotenuse. You could write it out, but now try to learn how to do it in your head. So sine of 66 is x over 3. So x is 3 sine 66. Which is 2.7. And check, and that's correct. Okay, now to solve each triangle. What does that mean, solving a triangle? It means finding all 3 angles and all 3 lengths. And if you want, you can also find the area. That would be quite nice. But they don't ask for that. Solving really does mean just find the lengths and find the angles. Okay, so finding the missing angle is pretty simple. It's just 180 take away these two added together. So 114, which will be 66. And you can just do that for all of them very quickly. $19 degrees, 57, 36. Okay, now missing lengths. So, well, okay, say if I want the opposite, I have the adjacent. So what do? Well, I can do tan. Here's my opposite. So (3.7 times tan of 66, 8.31. To the nearest tenth, that's 8.3. Oh, I know. Now I can get this side just using the Pythagorean theorem, right? And just feed in 3.7 and 8.3. Wrong. Don't do that, because this is an approximation. And this, you are you're betting that you did that 100% correctly. Maybe you did, maybe you didn't. It's actually better to see if you can get it using the information you were given in the first place. So what does that mean? Well, the information I was given is that this is the hypotenuse, yeah. This side here, 3.7, that's actually opposite to the original angle I was given, which is 24 degrees. Okay, so who mentions opposite and hypotenuse? That would be sine. So sine of 24 is 3.7 over the hypotenuse, which I don't yet know. So the hypotenuse is 3.7 over sine of 24. Which is 9.1. And that solves that triangle. All the lengths are known, all the angles are known. Okay. But did you notice that when I was finding the opposite, I didn't follow my own rules? Because I used tan of 66, which is bad. That wasn't an angle I was initially given, so there's a possibility that I didn't do 90 minus 24 correctly. And so even though I'm pretty confident that 90 take away 24 is 66, it's still a chance for error. So it's still not the best. So here I'm going to try and fix my mistake and actually follow my own advice. Okay, so let's see. So I want side BC. Side BC, I want the length of it. So, okay, that is how you name side BC. You write BC with the line over the top. And this is how you say the length of side BC. So here I go. Let's see. That's it's going to be the adjacent to 71. And 14 is the opposite side. So we have the opposite. So opposite and adjacent. Who's that? That's tan of theta. So tan of 71 is 14 over BC. Tan of 71 is 14 over BC. So that means BC is 14 over tan 71. Much better. We say 4.8. Okay, what about side BA, which is the hypotenuse? Pythagorean theorem? No. No, because you could be in error. So, what were we initially given? Well, we've got this 71 here, and we've got the opposite to it. So hypotenuse and opposite, who's that? That's sine of theta. So sine of 71 equals 14 over hypotenuse. So the hypotenuse is 14 over sine 71. Which is 14.8. And those sound reasonable. So let's check. Okay, that's all correct. That's all correct. Next up, this one here. Side AC, the length of side AC. Well, that's adjacent to the 33 degrees that we were given. And we were given the opposite. So opposite and adjacent, well, that would be tan. So tan of 33 is 14 over adjacent. So adjacent is 14 over tan of 33. And we get 21.6. Side AB. That's the hypotenuse. We were given the opposite and theta. So it's sine. Sine of 33 equals 14 over the hypotenuse. So 14 over sine of 33. Which is 25.7. Over here, side BC, that's adjacent. And we were given the opposite. So opposite and adjacent, that's tan of theta. So tan of 54 is 2 over adjacent. So 2 over tan of 54. That would be the adjacent. And it's 1.5 to the nearest 10th. Finally, side AB. We were given the opposite. And now we're seeking the hypotenuse. So that would be the sine function. So sine of 54 is 2 over the hypotenuse. So 2 over sine of 54. That would be that length. And we get 2.5 to the nearest 10th. And we check. And that's all correct. And that's good. And we take a breath here and be well.